So let's start with saying good morning. I just want to make this presentation conversational. So if you have questions, stop me, ask me the question as I move through. What we decided at IP Infusion after the success of London 2 project, that why not we take that configuration that LINX has and put it in a solutions. We call it a micropod DC box, and make it available to you. So the configuration that LINX has, currently they are using underlay IGP. You could use BGP as well, or you could have a choice for MPLS as well. So we'll make customizable configuration for you for this bundle. But before I get to that, let me talk about a little bit on IP Infusion and some of the exciting things we are doing at IP Infusion. IP Infusion contributed GNU ZebOS to open community, and that was forked to Quagga as well as FRR as of today. ZebOS, on the other hand, is a commercial version of GNU ZebOS. And this is industry proven. A lot of OEM vendors are using ZebOS. The same control plane is used on OCNOS for white box and VARNOS for NFV control plane. So you have a choice of 3 products to choose from. As I mentioned, ZebOS is the core control plane for OCNOS as well as VARNOS. And as you see, all of these softwares are modular and extensible. Here is a list of customers that using ZebOS. So ZebOS is battle hardened. It is industry proven software, and that's the same control plane we are using on other version of the software. OCNOS and VARNOS you could use in different network configurations, starting with internet exchanges, internet service provider, a cell router, or mobile backhaul scenarios, or mobile backhaul integrations, or xHaul for that matter as 5G moves on. Also, we do provide through our VARNOS VoLT functions. Also in OCNOS, through a container I will show you, we are also supporting OLT function as well. So for PON and aggregations, we do have the software for you. And the same goes for data center DCI functions as well as NFV's environment for UCPE, VCPE, or SD-WAN. So as you build, this is the 2 areas that we are working on as of today. On the right-hand side is a DCI environment. So if you build a hyperscale data center, this data center will look like exactly like this, right? You have a high power coming to your rack, and you have a BGP, ECMP, BFD based your class architecture. With that, actually you can follow RFC 7938 to build your network. But what we are doing with the BGP is that we have optimized the convergence. And we will disclose the number first quarter next year. We are shooting for 30 milliseconds for a very hyperscale data centers on BGP. Also for BGP, we will work on ROV, route origin validation, and other permutations of BGP that you could use in secured environment. Anyway, on the right-hand side, as I mentioned, we are working on both EdgeCore's Cassini as well as Facebook's Voyager. So with those 2 products, not only you could use it in DCI environment, but you could also use in metro environment, or probably currently we are shooting for 164 miles, but you could, going forward, will support up to 1,000 kilometers. So you could use those 2 products in a different scenarios for transport peering and so on and so forth, which requires long distance interconnectivity. On the left-hand side, you see container-aware network. What we have done, created an instance that also support BGP peering, and that instance will collect the information from various containers, from Kubernetes masters, and pass that information back to the BGP peer so that the network become on demand, right? And also, we have partnered with another company that will provide the telemetry information for those containers. For telecom networks, as George referred to, we are working with their platform as well as other platforms for cell router gateway. And mobile backhaul or mobile edge computing scenarios, you could create this same DC box that we are talking about, same micropod. You could just roll it in and create your micro data center for mobile edge cloud systems. And that, if you use Qumran, will support SYNC and 1588, right? So you will have a class architecture. Not only in the front end, it will support mobile, the cellular tower interconnectivity and GPS clocking back to the 1588. On the back end, it will also create a clocking network as a pure 1588 network. On the core side, if you are, George mentioned about some of the product he's coming up with, so does other ODM vendors. Jericho 2 is coming. Currently, Broadcom has Jericho Plus, but Jericho 2 based platform will give you 1 petabit of transport system. And we are working on Jericho 2 as of today to provide you up to 5 million MPLS path if a system is available. So the focus would be 2 RU box, 80 to 100 gig ports. We are also supporting Tomahawk 3 for 400 gig, right? So on the right-hand side, you see UCP or VCP, what you call it. Varnos will support with the BNF functions for those. On the bottom, you see OLT. And I have not shown here the provider edge. We do support Qumran MX-based provider edge switches. So on the bottom, you see where the OLT is. We provide Linux container on our Ocnos, so you could literally put OMCI stack and use your EMS systems to manage it. Also, if you are looking at termination for your PPP tunnels, you could use Varnos. If you create a data centers, or what we call it, some of the people refer to it as CORD. Now, CORD has different meanings. The meaning here is that once you virtualize some of the VNFs, we do provide through Varnos some of the portable, extensible BNF that you could use. Here is BBNG functions that you could use for that purpose. So these are the 4 areas we do support for telecoms. So talking about this DC box, it is all about giving you the flexibility for underlay. So let's say you want to use BGP as an underlay, you could do that. If you would like to use MPLS as an underlay, you could do that. If you would like to use IGP like OSPF or ISIS, just let us know. We'll configure the box, we'll customize the box. So the architecture clause is extensible. And I'll show you various different network scenarios that you could use this same class architecture, literally. And it is one-stop shop. You call us, we'll provide 24/7 to 365 technical support, right? So the idea here is that you take this micropod, as George was referring to, you roll it in to your network, do the experimentation, expand it. Here just I am showing how you could do it for a data center, and then deploy it, right? Work with us, and we'll provide you technical support and solutions guidance for that purpose. The next is if you want to build a telecom network. I have shown you some of the interesting product we are working on. Same idea, take this clause, put it on your mobile cloud edge, and then connect the cell site router on the back end and the telecom tower from RRH connections with CPRI. And then you can take the CPRI to eNode V, from there Ethernet down to cell site gateway router, and from there to this class architecture, experiment with your VEPC functions if you would like to do. Look at the latency, how it's working, expand it, and then go towards the core and deploy it, right? The same goes for cloud services as well as file hosting company. This is an example of one global file hosting company that I worked with. The same scenario, they have transport peering and some other scenario, but the core of it was class architecture. And the same thing applies over here, that you could experiment for this kind of scenario, expand based on it, deploy, right? Here is an example. It's a DC box example. What we have done for Morocco, city of Casablanca, we created their law enforcement network for CCTVs and so on. And this is currently in production. This is same as you can see, this class architecture. It was in partnership with Delta Networks. And the same idea. So what I am depicting over here is that this DC box or this bundle that we have created is not constrained by a particular network or particular network scenario. You could literally use in a different environment, right? Having said that, thank you. But if you have a question, I'm here. And I think I have some time, right?
If anyone's got any questions, but yeah.
Any questions?
Perhaps they can catch you later privately.
Thank you. Thank you for your time.